Hey, what's up, guys? Hey.
Hello everyone! I hope that you are all ready for a science lesson today. Welcome to Science 5, where your learning becomes easy. This is Teacher Molly. I'm your science teacher. Our learning competency is about relate the ability of the material to block, absorb, or transmit light to its use. Quarter 3, Week 3. Our objectives are: Number 1, enumerate and describe the different types of interaction of light to different types of materials. Number 2, classify materials according to their ability to block, absorb, or transmit lights. Number 3, cite examples for each type of materials. What can you say to our environment? Yes, our environment is beautiful. Have you ever tried watching the sunrise in the east? Of course, you've tried to see it and it's glowing. Am I right? How beautiful it is to observe the flowers that the colorful butterflies are landing on. Do you agree? Look at the waves. Oh, the color increased even more as the sun set in the west. Wow! It is very beautiful to observe the brilliance of the moving waves. The colors in the sky are beautiful, especially when there is a rainbow. No one can stop admiring it. All these beautiful things we see around us represent what you can learn in this lesson is how light can be blocked, absorbed, or transmitted by certain materials. Oh, here's a treasure box. Wow! Here are the words to treasure and put in our mind. Together, we spell it out and learn the meaning. INTERACT. Interact is to act upon one another. REFLECT. Reflect. Throw back heat, light or sound without absorbing it. When the sun's rays hit the earth, a lot of the heat is reflected back into space. BLOCK. Block. To obstruct someone or something by placing obstacles in the way or to block one's exit, to block up a passage. TRANSMIT. Transmit. To send or forward as to a recipient or destination. BOUNCE. Bounce. To rebound or reflect after striking a surface. ABSORB. Absorb. To take in something in a natural or gradual way. SPECTRUM. Spectrum. The intensity of light as it varies with wavelength or frequency. Again, make it loud. The words are interact, reflect, block, transmit, bounce, absorb, spectrum. Everyone, here are our guide questions as we go through our discussion. Number 1. how light interacts with different materials. Number 2, what materials can reflect, absorb, and transmit light? Number 3, how color of an object affects its ability to absorb heat. Number 4, what are the uses of materials that block, absorb, or transmit light? When colors of light are separated due to alteration of water droplets, these colors are very visible in a rainbow. A rainbow appears in the sky as a result of the reflection and refraction of white light from the sun as it shines through the water droplets in the atmosphere. The water droplets act as prisms that reflect, refract, and then split the white light into an arc of visible colors of light as seen in a rainbow. Sunlight is a combination of different colors. We can see the different colors of visible light using a prism. What is a prism? Alright, a prism is a transparent optical object with flat surfaces. It can be used to reflect light, breaking it into different colors of visible light, colors of the rainbow. What is visible light? Alright, the light that is visible to the human eye is called visible light. The visible light is only part of the electromagnetic spectrum, EM. The EM shows the entire range of waves present in a world. Colors are really various frequencies of light. Colors are ranked according to their frequency. We can have this order, Roy-G-Biv. Remember this acronym. Therefore, we can say that red light with lowest frequency has the less energy of the visible spectrum. How visible light affects the beauty of the things we see around us. The primary source of visible light is the sun. The visible light allows us to see the color that is not absorbed by the objects. For example, we see most plants as green because the leaves absorb all colors of the visible light except for green. Light can be blocked, absorbed, or transmitted by certain materials, and the color affects the ability of a material to absorb heat. To understand light further, we have to study how it interacts with different objects. This branch of science is called optics. Optics is the study of the refraction, reflection, absorption, and transmission of light. How light interacts with different materials. All right, let's find out together. Have you seen artworks on a stained glass? Stained glasses are seen in churches, museums, and even in some houses. The design on stained glasses are achieved through the use of glasses with various colors and hues. The light that partially gets through stained glass highlights the different colors and hues, making them a sight to behold. While light partially gets through a stained glass, some materials, like a wooden door, do not allow light to pass through them. There are also materials like the clear glass windows that let light shine through them. Light interacts differently with various materials. The different interactions affect the way we use materials such as refraction, reflection, absorption, transmission. What is refraction? Alright, refraction refers to the change of direction of a ray of light, heat, or sound when passing from one material into another. The bending of light as it passes through different materials is also called refraction. For example, the pencil in a glass of water appears bent because of the different part of the materials that interact with light. The part of the pencil that is not dipped in water interacts with the air, while the part of the pencil dipped in water interacts with the water. Light moves faster in air than in water. This is why the pencil looks bent. What is reflection? Alright, reflection is the opposite of absorption. When more light or heat energy bounced, reflection refers to the bouncing back of light when it hits an object. It means that the light or heat returns after striking a surface. It is simply reflected off. Some objects with flat surfaces, like mirrors, reflect light in a straight, predictable way. Some objects with uneven surfaces, like rocks, reflect light in a scattered way. Reflection happens when the light that hits an object is bounced back by the object. When we see an object, what we are seeing is the reflected light. What is absorption? Alright, absorption refers to materials taking in of light and not reflecting it back. For example, when light strikes a black surface, it is absorbed by the surface and nothing is reflected. Absorption happens when light gets through the object. When light hits an object, some parts of the light absorbed by that object and some are reflected back. Absorbance is the ability of a substance to absorb light or radiation. Different objects absorb heat at different rates. Some objects are excellent absorbers, while others are very poor absorbers. Generally, dark-colored objects absorb better than lighter-colored objects. Dark colors look dark because they absorb more light. What is transmission? Alright, transmission refers to the passing of light through some materials. For example, when light passes through a glass window, it is transmitted to the other side, allowing the light to pass through the window. What are the different materials that have different ways of transmitting light? Number 1. Transparent materials allow all light to pass through them. Clear plastic and glass windows are examples of transparent objects. Number 2, translucent materials allow some light to pass through them. Stained glasses and frosted windows are examples of translucent objects. Number 3, opaque materials do not allow light to pass through them. Concrete walls, wooden doors, and mirrors are examples of opaque objects. Opaque, a material which cannot be penetrated by light. Black-colored opaque materials absorb light, while other colored opaque materials and also the mirror reflect light. How do we see objects in different colors? We see object because of the reflection of light. When light strikes to the object, it gets reflected to the human eye. How does a colored material affect its ability to absorb more light? Well, the answer is simple. What we perceive as a color is really different frequencies of light. The primary source of visible light is the sun. The visible light allows us to see the color that is not absorbed by the objects. So, the color of an object is not contained within the object. The color is the result of the light which strikes the object and is reflected by it. White light is actually the combination of all the frequencies of light. When we see a red object, it means that only the color red is being reflected by the object. We see most plants as green because the leaves absorb all colors of the visible light except for green. A red shirt absorbs all the colors of light except for the red color. All other colors are absorbed by the red shirt. Black and white colors are different from other colors. White is a combination of all the colors. When we see a white object, it means that the object is reflecting all the colors of the light at the same time. This means it has all the colors in it, and because it has all the colors in it, white colors reflect light. Black, on the other hand, is the absence of reflected color. When we see a black object, it means that the object is absorbing almost all the colors of light and none of the visible colors are reflected. Generally, dark-colored objects absorb better than the lighter-colored objects. Dark colors look dark because they absorb more light, making them harder to see. How do colors affect the heat absorption of an object? Let's find it out. Alright, the amount of heat an object absorbs depends on its color. A simple way to measure how much heat a colored material produces is to measure the changes in its temperature. Since black is the absence of all colors, it does not reflect any of the colors, but rather absorbs all of them. Black materials have the tendency to absorb all light frequencies. The absorbed light energy is transformed to heat, which makes black materials hot. The more colors an object absorbs, the more heat an object is generated. The more colors an object reflects, the less heat an object is generated. Thus, objects that absorb more colors of light also generate more heat, making them hotter than the things that absorb less colors or reflect more colors. When a colored fabric absorbs light, it turns the light into thermal energy, heat. The more light the fabric absorbs, the more thermal energy it produces. When the weather is warm, which do you prefer wearing? Light-colored clothes or dark-colored ones? During summer, clothes in light color like white, pink, and yellow are more popular. White is the presence of all colors. White, therefore, reflects all the colors and does not absorb any of it. White object reflects all wavelengths of light. So, the light is not converted into heat and the temperature of the object does not increase noticeably. The less light is absorbed, the less heat is generated. So, during warm days, it is wise to wear white because it absorbs less heat and is more comfortable to wear. So, when the weather condition is warm, children should wear white or lighter colored shirt when playing. Meanwhile, black fabric absorbs all the colors of the light and is therefore warmer than white fabric, which reflects all colors. In black or dark objects, more colors of visible light are absorbed, and since more light are absorbed, more heat is generated, since light is a form of energy. So, clothes with dark colors such as black, gray, and maroon are preferred during cold weather. When a colored material absorbs light, it turns the light into heat. The more light a colored material absorbs, the more heat it produces. The colors of the spectrum appearing the darkest and most like black, violet, indigo, blue, and green will produce the most thermal energy. The other colors, red, orange, and yellow, will produce the least thermal energy because they appear lighter or more like white. So, what do you think the coolest and the hottest star would be if you observe the color of light from each star? Alright, red stars are the coolest. Yellow stars are hotter than red stars. White stars are hotter than red and yellow. Blue stars are the hottest stars of all. What are the uses of materials that block, absorb, or transmit light? Let's find out together. Number 1. Choice of clothing. Materials that block, absorb, or transmit light has many uses. They can be used as color designs for clothing. Black or colored materials absorb light, while the lighter or white materials reflect light. Lighter color is better on the hotter days to make you cooler because all lights are being reflected by it. While darker color is better suited on colder or rainy days to make yourself warmer as it absorbs all light frequencies. Number 2, robotic competition. In robotic competition, a simple robot makes use of reflected infrared light to detect their opponent, so usually robots are painted black or white. Number 3, sensors. Door sensors automatically opens when one person gets near it. It uses infrared rays or IF. It works by emitting and then measuring the intensity of light that is reflected back from an object or material near it. Number 4, heat insulators at home. The emergency blankets that are used to protect a person when he is exposed to freezing temperature can be used to block heat from the outside. You answer these questions to measure your thinking skills. Number 1, why do we see objects? Very good. We see objects because of the reflection of light. When light strikes to the object, it gets reflected to the human eye. Number 2, why do we wear light-colored clothes in summer? Very good. We prefer light-colored clothing in summer as they are good reflectors of heat and light. In other words, they absorb less heat. Number 3, how do you relate the ability of the materials to block, absorb, and transmit light to its use? Alright, since light is blocked and absorbed, opaque materials are used to block light, such as roof and wooden doors. And since light is transmitted, translucent materials allow some light to transmit, as seen in stained glass, where selected colors are reflected and some are transmitted in the form of artworks. On the other hand, transparent materials can transmit all light, such as clear glass windows that allow all light from coming in inside the house, and at the same time, one could also see the outside view. We should wear dark-colored clothes during cold months, because they absorb more light that make the clothes hotter. To summarize our lesson, these are the interaction of light with materials. Refraction, light is bent. Reflection, light bounces. Absorption, light is absorbed and blocked. Transmission, light passes through. These are the types of materials. Transparent materials transmit all light. Translucent materials block and absorb some light and transmit some. Opaque materials block and absorb all light. What did you learn today from our lesson? Alright! In this lesson, we have learned about the different ways by which light interacts with materials such as refraction, reflection, absorption, and transmission. We have also learned about types of materials classified depending on their ability to block, absorb, and transmit light, such as transparent, translucent, and opaque. These things influence our choices on how we can appropriately use materials. Precautionary measures. Number 1, avoid too much exposure to the heat of the sun to prevent sunburn. Number 2, avoid playing broken glasses and sharp objects to prevent from being injured. Number 3, avoid directly looking at the sun to prevent eye irritation and blindness. Now, I want to know if you really understand our lesson. Directions. Fill in the blank with the correct answer. Choose your answer from the box. Number 1, primary source of light. And the answer is sun. Very good. Number 2, the taking in of light and not reflecting it back to some materials. And the answer is absorption. Very good. Number 3, the scientific study of light and how it interacts with different objects. And the answer is optics. Alright. Number 4, the bending of light as it passes through a different material. And the answer is refraction. Alright. Number 5, objects that do not allow light to pass through them. And the answer is opaque. Very good. Number 6, the light that is seen by the human eye. And the answer is visible light. Very good. Number 7, objects that allows sunlight to pass through them. And And the answer is translucent. Very good. Number 8. The bouncing back of light when it hits an object. And the answer is reflection. Very good. Number 9. The passing of light through some materials. And the answer is transmission. All right. Number 10. Objects that allow all light to pass through them. And the answer is transparent. All right. Very good. That's all for now. I hope that you learned a lot. Learners, remember this. Hard work matters. Study hard. It will be worth it in the end. Thank you for watching. See you on my next videos. Bye!